Hi everyone, welcome to the video walkthrough of the Secret Message lesson inspired by Wonder Woman 1984 coming to theaters. Alright, this is the homepage of all the lessons and we're going to do the Secret Message one today, but there is also the super quiz lesson that you can try afterwards. Let's start. Cool. So, let's learn how to figure out what this note means. So we see unleash the power, the word why, some random date maybe, and then three other words that make no sense and some numbers. So we're going to use the powerful language of Python to figure out how to do this. So with Python, you can use any editor that you'd like, but in this tutorial, we're going to use VS Code, Visual Studio Code. So you can choose to download based on whatever your setup is. Mine is Mac, so I'm going to click on Mac. And then I'm going to download Visual Studio on this website. And I'm going to click the Mac downloader right here. There we go. Cool, we're downloading that. And then along with that, we're also going to grab Python. So we're also going to go here and download this version, the latest version that just appears on this yellow box. Cool. Now, I actually already have Python and Visual Studio Code installed, but you just run both of these. For Mac, you just run them with just the default settings, but for Windows, just as a caveat, for Windows, be sure to click on Add Python to Path when you're installing it. Cool. So once you have that open, you will have your Visual Studio Code. Now, we also need the Python extension. So you want to click on the marketplace, and then you want to search Python. And the first one that appears, linting, debugging, multi-threaded, you want to click on that one, and you want to install. I also already have this installed, but there's an install button right here, and then that should be good to go. Cool. So I'm going to pause right now and let you all install it, and then we will continue on with the lesson. Cool. So hopefully you have it installed, and let's go. All right. Okay, so let's start by creating a folder on our computer where we can find it easily and calling it ww84. And then we want to open that folder. I'm going to do that just through here actually. I'm just going to click open folder. I'm going to create a new folder right here called ww84, create, and I'm going to open this folder. And there we go. And you'll know it's open when it says ww84 in the corner right there. Cool, so we create a folder, and then we opened it. Cool. Now let's create our programming file. So we want to call it decrypt.py. So there's a little new file icon right here. So you click on that, decrypt.py. All right. Okay, so we can close the welcome tab, so let's just close that so we don't need that anymore. Okay, so it says as you're coding in Python, we will get some other powers to add to our editor, but we can ignore any other pop-ups right now. Okay, so let's first make sure that our command center works. So let's put up this print statement. Print the hello. Alright, and then you click this play button right here in this corner, and it should print right there. Cool, so that means everything's hooked up properly if that's playing. Cool. Nice, so yeah, we click the play button, and yep, we got an output right here. Great. Okay, so now before we get into actually decrypting the note, we want to cover some of the basics. If you already have some familiarity with Python, you can skip this part, but I'm going to go through this part with you guys. So the first thing we're going to learn about is comments. So comments are code that won't really be run. They're just for us to keep notes of stuff. So if we put this comment, and we can put it anywhere because it won't actually be run. So we can put it, let's say, below. And if you run it, you'll see that you get the same output. We can also put it above, and that won't change anything because it's not actually being run. So let's put it above. Once again, same output. We can change this text, so we can say, oh, foobar, let's say. And once again, nothing. But here, which is actually being run, we can actually change this. So we can call this one foobar. And you'll see now that's changed. Cool. So that's what comments do. So they're just for us so that we can keep notes of what we're doing. So yeah, we ran through this. Cool. All right, now there's also variables. So we want to explicitly remember things with a code name. So the code name is a variable name, and then we remember values for those code names. So for example, in this example, we have the code name of Diana, and we want to say that the value of Diana is Wonder Woman 1984. So let's try that. So I'm going to delete this for now. So Diana equals Wonder Woman 1984. And when you want exact text like this, when the value is a sentence or a bunch of words, you want to put them in quotes. So cool. So we now assigned the code name of Diana to the value of Wonder Woman 1984. All right, and then now we want to print what the value is. So let's say we do this. So now we have, I believe, which is an exact sentence, plus this code name. So this code name, this will replace this right here. So let's see that. Cool, so it worked. We can change that to anything we want. So we can also say, oh, what if Diana was actually Barbara? There you go. So you can change that name to whatever you want, and it's just a code name to the actual value right here. So cool. So yeah, so we ran this exercise, and we did see at first that Diana is actually Wonder Woman 1984. Cool. I'm going to pause here for a second and let you guys play around with it before we move on to the next part. Okay, so then we also have functions, which are Python powers. So these are things that we can almost set up like a recipe of steps to do that we can always do repeatedly after one after again. So for example, we have this function. So I'm just going to copy and paste it right here. So this function, and we define a function with this def word. So define a power function called chant, which takes in a code name of phrase, and then prints that phrase 3 times. So if we were to follow the example in the code, let's print this. Now you want to also be wary of how you tab things and how you space things. That's something that Python is really picky about. So you want to copy it exactly as is. So let's see. So if we do that, then we print Wonder Woman 1984 3 times because we have this right here. So we're printing this one. So this gets passed right here, and then this shows up 3 times right here. So now we can change this to anything as well. So we can change this to Steve Trevor, for example. And then that will print Steve 3 times. Cool. So yeah, so you can change that as many times. You can do it over and over if you want. So we can do this. We can do Diana. Oh, remember to keep the quotation marks. So let's do that, Diana. And then we can also do Max Lord. And because we gave Python this power or this function, we can call this as many times whenever we want right after we define it, and then we can just call it repeatedly as many times as we want. So cool, yeah. So so just like right here, they created the function and then they chanted it. So they called that function, and then inside the function it just printed out Wonder Woman 3 times, just like ours. Cool. I'm also going to give you guys a little break to play around with that as well. Try chanting your own name and see what happens. And maybe even try, you can also change the number of times you chant something. So instead of chanting it 3 times, maybe try chanting it 5 times. Here, I'll do that exercise with you. So let's say I want to chant my name 5 times. So phrase, phrase. So now it's 5 times. 1, 2, 3, 4, 5. And then now I want to change this to my name. And I'm going to get rid of these other two. Cool. And now we have my name 5 times. Alright, I'll still give you guys another couple seconds to pause and play around with that. Alright, okay, now let's actually get to the decrypting. Okay, so we have the weird message again, and we want to crack this. We think that this is actually a Caesar cipher, where all the letters are shifted. So Y, we think, is shifted by 13 characters. Oskaza is shifted by 918. Ohupo, ED. So all these numbers below are the shift, how much they're shifted by. Okay, so we want to figure out what they actually mean, though. So let's start with the first power that we're going to give, to shift a single letter. So what this would do is, let's say we take a letter O. If we give it a letter O, we want to give it the power, okay, if we give it also the number 1, so the letter O and the number 1, can we shift it to the next letter in the alphabet? So I'm going to copy and paste this, and then I'll explain on a higher level what's happening. There's a lot of functions that you haven't seen yet, so no need to get into the details of those right now, but feel free to search them up. But yeah, so let's see. So this function, it shifts by some amount. So this power, last a letter, takes a letter and shifts it by some amount. So what it's doing is it's taking the letter, first lowercasing it to make it all easier. We're going to have everything within the same casing. And then we're going to get the numeric value for it. So there's this concept of ASCII. So this is ASCII, and every letter, so let's say letter A, I can't really highlight that well, the letter A has a number associated with it, 65. The letter lowercase a has a number 97 with it. So we're going to use these numbers to help us. So we're going to get the letter, we're going to get the number value for it, and then we are going to add the number that we want to shift it by. So let's say we want to shift it by 2. So we get the number 99, and then we figure out what the letter is again. So we first get the letter, and then we now get the next letter. So we start off by anchoring at A, so meaning that we start off with, okay, every letter will start off at 97. We don't have any other special characters. So we start at 97, and then we add the amount. And then we return what the new letter is. So yeah, so that's kind of just a higher level explanation. Feel free to read you can search these functions up if you highlight over them. You can even go to definition if you wanted, but it's a bit messy, but I would just Google it so you can actually search Python word. And you can see more about this function. But I think for right now, we're going to stick with a higher level. So no worries about that. So let's go back to our lesson. Okay. So we have that. And then now we're doing it for every letter, but we need to do it for every letter within a word. So we're going to make this other function. So instead of just letter, for word. And what this one does is takes in a word and then takes in the amount to shift. And then for each letter in this word, it uses our lasso letter function. And then we have the word that we're going to eventually give back. So we add each shifted letter to this word that we're going to give back at the end. So for each letter, we go through and we go, okay, well, whatever letters we already have, plus the shifted letter that we're at currently. And then, yeah, so then eventually we will return a full word. And this for loop, this 4-letter in word, all that's doing is going through each single letter one by one. So let's say we were shifting the word letter, it would start with L, and then it would go, okay, well, right now at the beginning of the letter, we have nothing there yet. So all it's going to do is go, okay, what is a shifted L by, let's say, 1? Gets that letter back, and then we go, okay, now E. We already have the shifted L from before, and then now we shift the E, and then add that. And then we keep doing that for every single letter until we finish the entire word. So then we would do this 6 times, and then we'll have a shifted word in return. So let's try it. So we'll see this, and then we actually haven't called this power yet, so nothing's going to happen, as you can see. I can play it again. Nothing really happens. So we need to actually call it. So let's try on Terra. Alright, so let's see. We're on Terra. Cool, it's green. So what's happening here is it goes into this. So we first send it to the lasso word power, and we send the word Terra, and then we go, okay, for each letter, so for the letter T, can we shift it with the lasso letter power by 13? And then we get the letter G back, so then we put G in here. And then we go, okay, well then the letter E, can we shift it by 13? And then we get the letter R back, and we add that right after the G. And then we go so on and so on until we finish the word Terra. Cool. Awesome. Okay, so now we want to try that with our encrypted code. So let's start with the word Y first. So I'm going to put it right here, and by 13. So I'm going to replace this just so it's easier for us to see, but word Y by 13. What do we get? Jul. Okay, so it looks like, given this note at the top, July 4th, 1984. Cool. Okay. Let's try the rest. So I'm going to copy and paste this. So we're going to use this power over and over so that I still have the other ones to look at. So what do we have next? We have this one. Okay, so I'm going to paste that here, paste that here, by negative 18. Okay. By negative 18. By negative 18. And then what do we have after that? Ohupo. So let's put Ohupo here, here, and by negative 1. Okay, so negative 1, negative 1, and then we have ED. So put here, here, and ED is by 25. Okay, so 25 and 25. Cool. Okay, so cool. So we have the word shifted. So we have July, Washington, D.C. Cool. Okay, I think we cracked the clue. So, all right, let's see if we can test it. So we have some code here. Don't worry about the details of this exactly. It's just a little quiz to see if we actually cracked this properly. So let's paste this. Let's put it just below, actually. We don't need to delete all that. Okay. So let's run this quiz. So, what date will we travel? Well, we said July 4th, so let's put D. And then where will we go? Washington, D.C. Cool. It's awesome. We found the secret location, and we cracked it. Great. Good job, guys. Yeah, so if you want to compare your code with the completed code, you can click right here. Or if you want to try the next lesson, creating your own personality quiz, go ahead. Thanks, and bye.